Alright, so now let's talk about composite functions or function compositions. So if you have two functions f and g, then the composite function fog, this is basically read as fog here, or the composition of f and g is defined here as f of g of x. So notice it's very similar to the function notation that we were talking about before, with one big exception. It looks like the input into the function f is the function g. So function compositions are just a function evaluated at another function. Now that might seem confusing, but it's really not. It's just that now the input is itself another function. Now we read the following notation as f of g of x, because that is saying that the function f is a function of g, which itself is a function of x. Now, I want you guys to know that the order and the composition matters. In general, f of g of x is not the same thing as g of f of x, and this is shown here in some nice examples. So for example 10 here we have, suppose that f of x is x squared. I'll put this one here in blue. And g of x here is 2x minus 3. And we want to evaluate the following. First example is f of g of x. Now I'm not really that big of a fan of this notation. I always like to write it as f of, in fact let me put it in blue here, f of g of x. Okay, so what this means is that the input is g of x, and we're inputting that into the function f. Now what was the function f doing? Well, the function f was taking our input, whatever that may be, and squaring it. So we're putting the input of g and squaring it, which is going to give us here, what was the g? The g was the 2x minus 3. Okay, so we take the 2x minus 3 and we square it, again because the g was the input. And the function f was telling us to take your input and square it. So what do we get after squaring the 2x minus 3? Let's see. That's a 2x minus 3 times a 2x minus 3, which should give us, let's see, 4x squared minus 6x minus another 6x plus a 9. So that's equals to 4x squared minus 12x plus 9. Okay, so there we go. That is f of g of x. Now, what about g of f of x? So let's take a look. Are we getting the same thing? Let's see. Now we have g of f of x. So now the input is f, and that input is going into function g. Now what was the function g telling us to do? It was telling us to take 2 times whatever the input was. In this case the input is f of x, and then we took away 3. So let's see. Then that's going to be 2 times the input, which was the function f, which was an x squared. And we took away 3, so the answer is 2x squared minus 3. So as you can see here, it is very different from the composition for f of g of x. But overall though, hopefully it's not too bad. It's just recognizing that the input itself is another function. Now let's finish this section here with this nice example. What is f of g of 3? So what is f of g of 3? Now, the way I recommend working on these examples is by first taking a look at the input here. What is g of 3? Let's put it in orange here. So what is g of 3? Well, let's see. G of 3 is equals to, now if I recall correctly, well, we see it here. The function g was telling us to take 2 times the input and then take away 3. Well, that is 6 minus 3, which is equals to 3.